Okay, welcome back from lunch. Our first speaker post-lunch is Mr. Brian Lindblom. He has been a forensic document examiner for almost 30 years, having received his initial training at the Royal Canadian Mounted Police Central Forensic Laboratory in Ottawa. He worked in that lab for 7 years before opening a private practice in 1987. He's a member of the Canadian Society of Forensic Science, the American Society of Question Document Examiners, and the American Academy of Forensic Sciences. Mr. Lindblom holds a diploma from the Forensic Science Society UK and is an American Board of Forensic Document Examiners diplomate. Mr. Lindblom is a co-editor and principal contributing author of the Scientific Examination Question Documents, 2nd edition, published by CRC Press. Welcome, Mr. Lindblom. And using statistical functions of write-on software to assess natural variation in handwriting.
I'm going to change the title. I want to get statistics out of the heading and put occurrence frequency just to calm you all down. So my first question to you is, how many have used write-on software in casework? Okay, so at least half the class have. So you probably know then that write-on is really a database that assists the document examiner in doing handwriting comparisons. This presentation wasn't with the automated handwriting comparison section last year because it wouldn't belong there. The program does not attempt to give you an answer through its database, but rather just to assist you in doing your own examinations. So you can use it for the collection, dissection, and analysis of data, and the results are also very useful to aid in courtroom presentation as well as making demonstrative charts for reports. It's primarily been used for extended handwriting comparisons, but it has application to many other areas. For instance, there has been some Swiss research done in Lausanne, Switzerland, using it for typeface database and identification. Once the handwritten images of the question and sample materials have been scanned into the database and then a typed transcript prepared of the handwriting that has been scanned, you then associate the two, the graphic image and the transcript, and once you've done that, you're able to launch a whole variety of sophisticated searches to help in the assessment of the handwriting characteristics. And from my perspective, its greatest value is fully assessing natural variation in the handwriting, and that's going to be the focus of the presentation today. So the searches that you conduct generate what are termed occurrence charts, and this allows for the side-by-side comparison of words, letters, letter combinations, numerals, symbols, punctuation, anything that is found within the written question documents can be searched for. Because of the versatility of the searches, it ensures that you can make a full assessment of the natural variation for whatever particular character or search string that you're dealing with, and you will see an illustration of each particular character that you're searching for. The program maintains a record of all the searches that you've done. So in situations, for instance, where you go back to court 1 year after doing your exam, if you wish to review the results of your analysis, you can go back in and look very quickly at all the saved searches. So you don't have to, in a sense, launch them again. You simply click on an existing search and it opens immediately because it's already been saved as information in the database. Of course, you can also use that live in court to show the various examinations you've done and launch a search, and it's excellent for aggravating the opposing attorney in a very effective way. So the illustration that you see on the screen right now shows a word index that is generated as part of the functions of the program. So it will show you every word that exists in both the questioned and the specimen material. So from this word list, you can very quickly find out how many of the words in the question document actually appear in the sample material, and then you can launch searches looking for those words. So you don't have to waste your time looking for a word that does not appear in the sample material. This program tells you instantly whether there's a point in attempting to do the comparison. So this is an enlargement of the full word index, and what we have here is the word that's being searched for, the number of occurrences within the question document, and the number of occurrences within the sample material. So in this instance, there's no point looking for the word wherever because it doesn't exist in the sample material. But for instance, if you need to do a search for the word the, you will know that there's one occurrence in your in your question material, and one in the sample material. Here's an example of a search that I conducted where there were 3 instances of the word they in the question material and 7 instances within the sample material. Underneath each image, you will notice that there's an identification label. That label tells you the search string or the word that you were looking for, what document it's found in, and what particular writer it is. So you can very quickly identify the location of the particular word or search string within the documentation. I'm just going to zip up quickly because I think I've slipped a slide here. No, I haven't. At the bottom of the screen, for each panel or column, you have the total number of occurrences for both the questioned writing and the sample writing, and of course you can see in this instance that there are 10 occurrences in total. Once you've brought up the search string on the screen and launched the occurrence chart, you can very quickly look at the actual word within the document. So in this instance, if we were looking for the word they, if you right-click on this particular image, a View Map or Send to Report drop-down appears. If you click on the View Map, another window will open and you'll actually see the location of the word within the document itself. And why that's important is you might want to look at the spacing that surrounds the word, the alignment of that word relative to the surrounding information or in the context of the paragraph itself. And you can do this for any of the images that are generated in the occurrence chart. An even stronger search option is called the segment index. So segments are anything other than words. So it could be the numbers 0 to 9, all the letters of the alphabet, as well as frequent letter combinations. So when this program was developed, the designer, Pierre Goudreau, and I went through and looked at what letter combinations would be the most useful for document examiners. We focused on French and English just because of the 2 people that were working on that aspect. So we've included things like ED, ING, ET, TH, and so on, very common letter combinations. But you can customize this to include any letters, any combinations or numerals that you want. So if you're working on a particular type of document where abbreviations are used, you can customize this table to include those abbreviations. Or saying you're working in Spanish and you want to add some classic letter combinations in Spanish that you don't find in English, you can add these to the database and launch searches directly. So here's an example, for instance, where if you wanted to look for an ING combination, you can quickly find out that there's 5 in the sample material and 27 instances in your specimen material. So one of the other things it tells you very quickly is, do you have a high number of occurrences within the specimen material that will allow you to assess natural variation, or might the number be quite low, such as, for instance, I guess we don't have a really good example here, but suppose there was an IE combination in the question material. In this instance, you would only have 2 sample materials. So you can probably assume that in terms of range of variation, you don't have enough material to work with there potentially. Now, just imagine how long it would take you say within 30 pages of sample documents, to locate the 27 instances of the ing combination. If you use write on, you will have it in 3 or 4 seconds. So one of the benefits in using the program for this is you avoid one of the human factors, fatigue. So if you've got a large amount of documentation to look at, this program does the search for you, shows you the images, and you can go quickly to the original documents to review the handwriting characteristics, therefore reducing a lot of the fatigue that you encounter when you have a high volume of documents to deal with. Now, this is the search list for a particular case that I was working on, and you can see that it shows you the whole inventory of words and letter combinations that I searched for in my forensic examination. Now, if you were to right-click, I'm not going to do it because this is just a PowerPoint image, but if we were to right-click, on this search that I made for the word Sarah, it would tell you other details about that search. If we took the TH example above Sarah, if I right-click on that, it will tell me whether the search I conducted was for a TH in any position within a word, or if I limited the search to just the initial position or the terminal position within the word. That data is all available from the search list, so it's very powerful in terms of reference purposes. Okay, so I think most of you in the room probably received a document over the last couple of days called the scotopic sensitivity test. If you don't know what scotopic is, it's irrelevant. It's actually got something to do with speech pathology, but is a convenient document for this little exercise. So the task was to go through the 4 pages of handwriting and identify every instance of the EN combination and the TI combination. The reason I asked you to do this is we did a quick little experiment at the Midwestern Association of Forensic Science meeting in the fall of 2012. There were 13 examiners taking a workshop on how to use write-on software, and Pierre Goudreau and I just asked each participant to go through this sheet and circle all occurrences. There were 24 occurrences of the EN and 14 occurrences of the TI. So you're not to tell me how many you found, but if the maths results are indicative of what probably happened in this room, the great majority of you will have missed some of those letter combinations. And what's surprising is it's only 4 pages of handwriting. In the context of the exams we do, that's very trivial, and yet we miss as many as 3 or 4 instances of each of these letter combinations. My hypothesis is the reason we miss them is because they appear at very different places within words, especially the TI combination, which could be at the beginning, in the middle, or near the end of the word. I failed this. When I made the test up, I knew how many of each occurrence there was, and I still didn't find them all when I did it the first time. So I think it's very easy to miss instances of a letter combination, which translates into potentially not assessing the full range of natural variation that's available to us. Anybody get perfect?
Do you count the TIs and the printing on the top of each page?
As long as it's handwritten.
Doesn't say that on the instructions.
I didn't want you to get it right, John Paul. Okay, so what did we learn from this trivial little experiment? And granted, you did this while you're out having supper or meeting up with friends and stuff. It's not a real forensic exam. But I think what it shows us is that even with a very small amount of handwriting, there's potential to miss instances of a given combination that impacts on the assessment of natural variation. And I think the likelihood of missing a particular instance of a character or character combination increases depending on what particular character is being searched for and also where you might find it. take an example of having 50 pages of sample handwriting and there's only 2 instances of an ES combination within those 50 pages. Based on this simple little test we did now, what are the odds that each of us in the room would find those 2 examples? I would say very low, that we would all find it. Some of us probably would, and think of it in the context of that's just one of 400 searches that you're making looking for particular letter combinations. In some of the illustrations that I've been showing you of the searches that were conducted, there appears within those particular documents that I was using the word ON, and also it's embedded within words just as a letter combination. It appears 4 times within the words in question and 71 times within the 19 sample documents. So potentially this is an ideal comparison to be doing because 71 instances of ON should reflect a broad range of variation, or it should allow you to assess the full range of variation with such a high frequency. But of course, because we're looking for ON, we can expect to find it right at the beginning of the word, a bit further in, towards the end, or at the very end of a word. So there's a good chance that we might miss it if we look for it manually, but if we do it in write-on, we don't have to worry about that because the program is going to show us each instance. So here's a screen capture of some of the instances where the ON combination appears. So on the left-hand side, you see it in 4 examples of within the question documents, and then on the right-hand side, I'm just showing you a small snippet of the 71 examples of the ON combination, and you see that it appears in different locations within the words. So how can we alleviate the problem of missing instances of particular letter combinations? Well, the program ensures that you can look for every instance because as long as you search for every combination and every word from the word index and the segment index, you should be able to examine everything that's pertinent within the document. Once the search is launched, you can do the side-by-side comparison on the screen, or you have the option to print the occurrence charts out and make notes on the hard copies, which can be quite useful, although it does tend to generate an awful lot of paper, but it's readily available to you. It can also alleviate unnecessary searches. So the highlighted areas show you 6 instances where a particular letter combination or individual character appears within the within the question material, but there are no instances within the samples. So there's no need to be flipping through your documentation looking for those characteristics because they aren't there. I think another value to the program is it helps you to assess whether you've got an adequate amount of comparison material to truly see the full range of variation for a given character. So in this instance, I searched for the numeral 8. It occurs once in the question material and 2 times within the sample material. So I guess the question I would put to you here is, with those 2 samples, and the obvious differences between those 2 samples and the specimen material, are we in a position to say this is probably a different writer because the letter's fundamentally different? My answer to you would be, I don't think so, because you just don't have enough material to work on. So they're not accounted for features. Sure, there are differences, but would you put as much weight on this example as you would, for instance, searching for the numeral 2, where you have 18 instances of the numeral in the sample material, or searching for the 0, where there's 24 examples in the sample material? And like I said, you get a log of all the searches that you've made, so you can go back and assess that when you're reaching the point of rendering a conclusion. So I think it's quite helpful in that respect. All right. It's also an extremely powerful tool when demonstrating flawed methodology by another examiner. So my wife told me I cannot say who this examiner is in this real case situation. However, at least two of you in the room know exactly who that person is because you also worked on this file. So this was a high-profile extradition case that happened in Ottawa that some examiners worked on over about a three and a half year period. And to say that there was a flawed methodology is a gross understatement. There were extremely serious problems in the approach that the examiner, in this case from France, used in rendering an opinion. So a group of about 5 of us were asked to do detailed reviews of this person's findings and render reports. Because it was an extradition hearing, we were forbidden from actually rendering our own opinions, but we could comment on the data and findings produced by the expert from France. One of the items included in this expert's report was a commentary in the English translation of the report that feature number 32, as she has identified it, being an X, wasn't accessible because it could not be found in both the questioned and sample material. So if you have a write-on, you can quickly check and see if that's actually true, which we're going to do right now. That's how long it takes to discover that, of course, there's an X in the question material and an X in the sample material. So we were all able to show that the suggestion that you can't compare the X is false because it appears in both the question and sample material. In another part of her report, she had identified that there were 7 differences between the question and sample material, but ultimately said in a rather convoluted way that these were not real differences because they're just variations that didn't happen to show up in the material we examined. A rather novel approach to dealing with that. One of the characters that was distinctly different was an uppercase P with a rather large embellished oval at the top. There were 25 samples of that P within the specimen material, but apparently we still shouldn't expect to see that shape appearing within 25 samples. That defies logic, and as you'll see in a second, we can bring up to 25 examples, and if you look at the 2 obvious characteristics in the P that the arrows are pointing to, the flourish at the beginning of the P starting well to the left-hand side of the staff, and then the elongated horizontal oval, just from the few examples that I'm showing you of the 25, obviously that letter form is not accounted for in the samples and actually is a true difference, not an unseen variation. So in this case, we used extensive charts generated from write-on to show that the methodology was flawed. In some cases, we had as many as 200 to 250 examples of a given character, all being different from what was seen in the question material, and we presented this to the judge to show that the person was obviously not being objective in identifying true differences, but was simply writing them off because it was not convenient to the conclusion that she wanted to render. And that concludes my presentation.
Okay, we have 3 questions from the interwebs. Brian, are all the images in the occurrence chart shown to a 1-to-1 scale? Thank you.
In this particular case, I think they were enlarged. You have the opportunity to increase the scale to any degree you want to make them sufficiently large for examination purposes.
Thank you. Next question, does the program support high-resolution scans so that you are seeing good quality images and can print good quality exhibits from the program?
Yes, it can. However, I would say that if you scan at a high resolution in color, you're asking for troubles because the file size becomes very large. But we routinely do scans at 500 to 600 dpi in grayscale, which is adequate when you factor in that you can also enlarge each image.
Okay, next question. Do you know if many examiners have actually used the write-on program in court? And is there any knowledge about their experiences with it? In other words, has it backfired in any way?
No, I know a number of examiners have used it, as have I, obviously, given from what I've just said, and that it's been very well received in the particular instances where I have firsthand knowledge. And I don't think it'll backfire on you. I think it will backfire on the person cross-examining you, because you can easily retrieve the data to support your findings.
Two more popped up.
They're all coming from my office, by the way. I wrote
Presentation. Have you written a technical procedure for utilizing software for use in casework? And is it available to the document community?
Can you repeat the question?
Have you written a technical procedure for utilizing software for use in casework?
Not a formalized procedure, no.
Okay. And last, is write-on error-free? For example, can transcription errors occur?
Well, the answer is obvious, yes, because humans are typing in the transcript. You could misinterpret what the actual graphic image says. You could put in a typo. You could miss words. So the errors can be produced by the document examiners. There's no way write-on can correct your transcription errors.
Are there any questions from the audience?
I've got the microphone. Brian, I don't know. I like the software and what gets produced, but I know a lot of examiners don't like the prep time on the front end. It's so lengthy. Has that? I know that this was years ago. I mean, I know advancements in technology. Is it easier now, faster at all, or is it?
I don't think it takes any more or any less time to type it in, but I can tell you that I've used this on hundreds of cases, and it typically, say for a file with 10 to 15 documents, we usually have it up and running and doing the searches within 1 to 1.5 hours of scanning in and typing the transcript. And if you weigh that against the benefits, the search power, the reports you can generate, I think it easily offsets the input time. Just imagine searching for 71 instances of a given character manually versus having it in a matter of seconds using the program.
Is this software PC based?
Pardon me?
Is the software PC based?
Yes, but you can adapt it to work on a Mac as well. The other time.
Hi.
One more question.
Okay. Does this software account for the difference between the question document versus the sample being an original and the question document being just a copy of something? Does the software account for the difference, or you just look at visually?
You're just looking, well, you're inputting the material, so if you only have copies versus originals, obviously the graphic images will just reflect that they're copies. It cannot improve the quality of what's been inputted.
So it doesn't make any difference whether it's an original that you're comparing it to or a copy?
Well, it only makes the difference in terms of what a document examiner is faced with in every single case.
Thank you.
Thank you, Brian.
Thank you.